For tens of thousands of years, the delicate balance of Earth's climate has allowed human life on our planet to thrive. Today, that equilibrium is at risk as one of the most important cooling mechanisms, the albedo effect, or Earth's reflectivity, is threatened. At Earth's poles, snow and ice reflect up to 85% of the sun's rays away from the surface and back into space, helping to keep the planet from becoming too hot. But over the past few decades, this natural mirror has begun to break down as fossil fuel emissions raise temperatures, melt snow and ice cover, and reduce the planet's albedo. As the planet loses its ability to reflect sunlight, a dangerous warming feedback loop is triggered. The most alarming change is happening in the far north, where the temperature rise is causing the snow cover and sea ice to rapidly disappear. Don Perovich is a sea ice geophysicist at Dartmouth College. For the past 30 years, he's been documenting big changes in the Arctic.
There's always been this annual cycle. The ice grows, usually say for 9 or 10 months of the year, and then melts for a couple of months. What's changing now is the timing. The melting is starting earlier, the freezing is starting later. We have much less coverage every month of the year, particularly at the end of summer.
Global warming from human-caused emissions of heat-trapping gases, carbon dioxide, methane, nitrous oxide, and others, is increasing the temperature in the Arctic 2 to 3 times faster than the rest of the planet. Warming is then amplified by the loss of albedo as the reflective ice and snow disappear, exposing the dark ocean underneath.
Say it's April, and we're flying above the Arctic and we look down at the sea ice cover. It's covered by snow. It's bright and it's white. Now, summer comes, that snow melts, you get more open ocean, you're absorbing much more heat. Instead of reflecting 85%, you're absorbing 90%. And so you're replacing one of the best natural reflectors, snow, with one of the worst, the open ocean.
Now, instead of reflecting the sunlight, the ocean absorbs it, heats up, and melts more ice, exposing more dark ocean, which absorbs more sunlight in an amplifying cycle.
As those darker waters warm, they emit carbon dioxide and water vapor, warming things further. So there are several aspects to this feedback in the Arctic problem which are truly frightening.
Scientists have been measuring Arctic sea ice since long before satellites began taking reliable measurements in the early 1970s. By the end of that decade, the climate models predicted sea ice would begin to disappear with the increase of heat-trapping gases in the atmosphere. Marika Holland is a climate modeler from the National Center for Atmospheric Research.
So our first climate models were developed in the 1970s. Those models, even in their simplicity, predicted that with rising greenhouse gases in the atmosphere, we would see dramatic sea ice loss in the Arctic, and the Arctic warming would be amplified relative to the globe.
And as measurement techniques improved, scientists were alarmed to discover just how much ice had been lost.
The volume has decreased by 75% in only 40 years. It's just a breathtaking change in a very short time. We call it the New Arctic now because it's so different from what it used to be. The ice now is mainly consisting of what we call first-year ice, which is just ice that's formed in that one winter. And most of it doesn't survive through the summer, it all melts.
Studies suggest that around a quarter of global warming is caused by the loss of this sea ice. But if you factor in the melting of snow cover on the surrounding land, together they account for an estimated 40% loss in the planet's reflectivity.
The snow cover over land is very bright and very reflective, it reflects an enormous amount of the sunlight away from the surface, just like the sea ice cover does. And we are seeing reductions in the aerial coverage of snow over the land, just like we're seeing reductions in the aerial coverage of sea ice.
With feedback loops amplifying the warming, the landscape of the Arctic will change irrevocably.
So our climate model projections suggest that we will lose the Arctic sea ice cover in the summer months altogether by the end of this century. If we continue to increase greenhouse gases in the atmosphere through the burning of fossil fuels, we ultimately will get to a state where we lose the winter sea ice as well.
A sobering prediction, considering that ice has covered the Arctic Ocean for more than 2.5 million years. And the warming happening in the Arctic isn't staying in the Arctic. The air there is mixing into the global atmosphere elsewhere on Earth and raising global temperatures.
The Arctic plays a very central role in Earth's climate. Even if you just lose sea ice cover in the Arctic, the tropics will feel that enhanced warming.
This means amplification of problems the climate crisis is already causing. Crops suffering, food prices going up, wet areas becoming wetter, dry areas becoming drier. And as the climate warms, it kicks in another feedback loop, set in motion by the melting of massive glacial ice sheets. In the past 30 years, the loss of ice on the Greenland ice sheet has increased sixfold, leading to a rise in sea level. As the ocean rises, the higher, warmer water melts more land ice, raising sea levels further and melting even more ice in a vicious cycle. In the South Pole, the increased temperature is thawing the miles-thick Antarctic ice sheets that have been accumulating on land for over 40 million years.
Loss of ice over the Antarctic continent doesn't have as much of an albedo feedback because it's so thick. But as that ice enters the ocean, it causes sea level to rise.
If both Greenland and Antarctica's glacial ice shelves were to melt, sea levels would potentially rise by more than 100 feet. This resulting destruction to coastlines would uproot millions of people around the world. It would also mean the ice sheets would reach a tipping point, taking thousands of years to recover.
If we lose an enormous amount of ice from the land, reestablishing that is a very long timescale issue.
And if we continue with business as usual, the warming of the Arctic will cause the feedback loops at both poles to spin out of control.
The models predict if we continue on the path we're on, that the Arctic will experience very dramatic changes and that those changes will reverberate throughout the system, the human system, the biological system, the socioeconomic system.
With every country contributing to the problem, each now needs to be part of the solution.
That requires managing the world in such a way that we do not exploit carbon compounds and dump the waste into the atmosphere.
The emission of greenhouse gases is an example of a market failure. One business enterprise passing on the real cost of doing business to people who aren't party to that business. That is, most of the rest of us.
In every sector of the economy, we have the technology and knowledge to move toward sources of energy that do not produce heat-trapping gases. What we need is the will. We must stop adding fossil fuels to the atmosphere, which are warming the planet, melting the ice and snow cover, and lowering the reflectivity of the Arctic. If we cut emissions, stop deforestation, and regreen the Earth, we can slow, halt, or even reverse the feedback loop. Lower temperatures, regenerate snow and ice cover, increase reflectivity, and heal our planet.
You have all this heat in the ocean. It would take a few years of cold temperatures to get rid of it, but once you did, you would get ice to form again.
The most important thing citizens can do is to educate themselves on this issue and vote for politicians who take this problem seriously and have good ideas for how to solve it.
I'm optimistic by nature, and I become more optimistic when I see so many people that realize there's a problem. The pessimistic part of me says the longer we wait, the harder it gets. It's time to act.